Hi, today we are going to cover one of the topics that is more interesting from my point of view. So it's one of my favorite topics. This short video clip is about logistic regression. The idea is that we want to get to know binary outcomes. What is that? Well, binary outcomes such as is there going to be a recession or not? It's time to sell a share, not. It's time to buy in Forex, yes, no. So it's very interesting because of that. And for everything, you have some probabilities of the positive result happening. So that is why it's so interesting for everything. So let's go to my full desktop and let's analyze these slides. And I think what you are going to enjoy the most is the example, because it's just fantastic. You can do many things with this. Okay. So we start actually here. Forecasting analytics, we are going to use the chapter 8 of our textbook. And this is about forecasting binary outcomes and logistic regression. So we are going to perform a forecast of a binary outcome. Again, binary outcome is a yes or no. Yes, we want to know at what extent is going to be yes something, or at what extent is going to be no the other result, right? Yeah. Okay, so here we are. I think you understand that it's very interesting to try to forecast the direction of certain market. So we have here many shares. It will be fantastic to predict whether a recession is going to occur or not. Yes, that is a binary forecast as well. And it's going to be as well fantastic to get to know if a certain threshold is going to be met or not, right? So yes, so that is what we can do then with this type of forecasting. So we are going to use logistic regression. Here I have an example. We are using this file that is in your folder data sets. This is GBP USD binary XLS. For those who do not remember, this is the British pound against the dollar. And yes, so here I downloaded the monthly closing price for the British pound, and I calculated the returns. The returns are simply the difference between one month and another divided by the first month. Yes, so that they are the result, the returns. Particularly here, I am very interested in returns that are higher than, say, certain threshold, right? Because obviously, if you want to invest in certain markets, such as in the British pound against the dollar, what you would like to know is at what extent you can be sure that the price is going to move, for instance, 100 pips or 1% or 2%, right? So instead of having here the returns, I change these returns by zeros and ones. Once, when I believe that there are good opportunities to sell. So when this threshold is, I think, is higher than minus 1%, right? That is something that 1% I want to catch it with my trading. So I will put 1 when that happens, and 0 when the threshold is not met, such as in this case here. I wonder if you can notice here the 0.007, that is less than 1%, right? So I would like to catch this one, minus 5%. That would be fantastic to catch that minus 5% in the whole month. Obviously, we can do this using less granularity. So for instance, if we can download the daily prices here, I think that would be even nicer, more bold, like a forecast. but for the purposes of this example, I think this is fantastic. This is good. I hope that in the seminar, that is the seminar in week 20, this is the lecture for week 19, the seminar for week 20, we are going to come back to this, yes, and talk about an example about forecasting binary outcomes using something very real. Yes, I have been thinking of using Bitcoin. Why not? We can use any other thing, but yes, let's see. All right, so if you do not remember what is the training period and the validation period, please refer back to my previous lectures. This is the training period and the validation period for this dataset, right? So we did the partitions, this is the time span, this is the time span, and we use this this column cell. Remember that name, column cell. Okay, it's time then to explain a little bit about what is the rationale of logistic regression. We already said that is binary outcomes. Yes, so we can what can we do? We can model cross-sectional data, meaning that we can model very interesting results in not just in the time but in the cross-section data. We can also predict binary outcomes. Yes, for instance, fraud or non-fraud, buyer or non-buyer. We can forecast like an event happening or not in general. And this is called classification in data mining. So in data mining, we use this actually for making robots. Yes, they go classifying shapes, for instance, and they are able to walk, or they go classifying patterns in the exchange rates, and then they are able to invest by itself, etc. And obviously, a robot can look at hundreds of assets at the very same time, look at the right pattern, and then send you a signal to you, and with a little bit of human intervention, if you want, then you just click and enter in that trade. So we are actually not very far from that if you understand very well this session. So alright, what else to explain and describe different between classes as function of input variables, so you can distinguish between males and females, poor and rich, online and offline users, etc. Right? So we can use that as well as an explanatory variable for our logistic regression. Also provides output similar to linear regression, and that is very handy because we have the coefficients and we have a statistical significance. Remember that the statistical significance is the p-value that appears in our tables in R, and this needs to be less than 5%. I mean, you can have 10% as well, but that will be something like having 40 in one of your assessments. Yes, pass. Let's pass, right? But 10% is actually very, very, very bad. I mean, you cannot, if you are using 10% in medicine, imagine you killing 10% of the population if you are developing a vaccine. It would be catastrophic. In economics, for us, 5% is okay. As the young people say, allow it, right? Okay, so here we have the logistic function. So all of this is possible. The binary outcomes is possible because someone designed a logistic function. So let's see how it works. First of all, we have the cell t, which is, remember, our variable here. Cell is this is this column with zeros and ones, 0 for no, 1 for yes. Yes is that it's meeting our criteria because we want to sell the GBP dollar, for instance, and we want to know what is the probability of cell equal 1, right? Of that column equal 1. And that is the probability that we are going to calculate. So the odds of cell equal 1 is equal to P divided by 1 minus P, which P is the probability of that column being cell equal 1. The difference between the probability and the odds is that the probabilities measure, for instance, from a basket, you can if there are like 6 balls and one of them is yellow, only one is yellow, so you have the probability of 1 divided by 5 opportunities that you are going to get the yellow ball, right? However, the odds is different because the odds measured in the denominator your preferred outcome. In this case is the 1 yellow ball, and in the denominator is going to measure the known favorite options. So in this case the 4 other balls, so it will be the probability will be 1 divided by 5, whereas the odds is going to be 1 divided by the non-favorite not favorable ball, which is the other 4 balls, 1 divided 4. That is the difference then, and the relationship as well, the probability and the odds. So you can see like a short video in YouTube about probabilities and odds. I think it will take you a couple of minutes if you want. We started actually, I allow like another video from another place, a couple of minutes just to explain what is probabilities. All right, I think this is not rain. I think this is a little bit confusing. This is GDP or cell, our column cell. So we have then that the logit, yes, the logit function. This is the logit function. This is, I think, one of the most important developments for the logistic regression and for many applications in machine learning for robots. As you can see, we have this sigmoid like function. So from here, guys, we have like a neutral position, but here it starts the probability being higher to be no, and here probability higher to being yes. Yes, and this is very in line with this. Look, yes, as you can see, these are the odds, yes, room, and they go exponentially, and they are exactly at the same point when we have this cross here with nothing. Yes, there is no decision, but here it goes to yes, and here it is no. So here we have the odds in our against us, and here the against favoring us. So the odds is a term used in whole races. So for instance, an odd of 2 to 1 means that the event of interest is twice more likely to occur. So and corresponds to 2 divided by 3. Yes, this is the probability. These are the odds. I think you have seen this, for instance, in pages such as Bread Freighter and things like that, in which you are able actually to bet. And I think this topic as well works with those pages. Actually, I was looking today at at one example from there, but I decided not to put it in this video because it will take too long. But if you go to those pages, you will see these odds, and they are very interesting because we can model them here as well with logistic regression. Okay, so as that function that logit function allow us to model this, the yes and no, right? Here is no, for instance, here is yes, here are the probabilities in this axis. So we are able then to run a regression. So we can run the logit function of cell t when it equals 1, and we can make that function depend on the same variable cell in the previous time. We can add also other variables. In this case, as an example, I am using sin and cosines, but to be honest, this can be, I think with this capture the seasonality. If you remember the sin and cosines, they will make like somehow like some cycles, right? It's not necessary. I think this is just for the example. So this is the logit regression, and the odds of the same function will be the number e to the exponential of this same equation that is in here, right? So this is the way in which we calculate the odds of something happening or not using the logistic regression of cell, right? This is a number that has been developed, so we can go and find what is the number. Yes, number E. Let's put here number E, and then you will find here the number E. Sometimes they call the natural number, or the Euler's number, is an important constant, approximately equal to 2.71828. So if we put that constant, yes, to the exponential of this function, we will get the odds. Very interesting, that Euler number, right? And very useful for many things. Actually, this Euler number has an inverse, which is the logarithm. And that is very important, because if you apply logarithm to this thing in the exponential will go down, and the E will get like the constant E, it will be 1. Yes, so we will be able just to get this down by using logarithms, because that is the inverse. All right, so we have now the odds, and we have that the probability, yes, the probability of cell equal 1 is 1 divided 1 plus E to the exponential of the same function, which are the odds, right? 1 divided by 1 plus the odds. Yes, remember guys, that we covered that in our previous equation. Yes, right? Yes, so if we do that, I think if we follow those equations, we will arrive to this, and we can generalize everything. Yes, the probability of cell equal 1 is 1 divided by 1 plus E minus to the power of minus the logistic regression, this regression that we have here, logistic regression, right? So that is the generalization. I don't want to go like very deep into the numbers, or you can do. I think will be great if you go into more details, but I don't want to get you stuck in the many details of the mathematical calculations. This logistic regression is going to help you to find, because of the logic equation, is going to help you to find binary outcomes, because it's going to classify cell accordingly a probability following that curve. Right, so here we have then again I have here the same problem, maybe because I was using yes, but we have here the logistic regression. Yes, when the cell equal 1, our preferred case, is equal to the thing that we had before. So we can calculate this by least squares, or as well by maximum likelihood estimation. This means that there are many methods, or this couple of methods, in order to find the best fit for our data using logistic regression. These are just methods in order to try to find the best accurate, or the best fit in our regressions. Usually, I think you have used least squares, or OLS. Yes, but maximum likelihood is as well an option. Maximum likelihood, what it does is to create random cases and maximize among those random cases what is the best. Yes, and it gets closer and closer to the best solution by creating random estimations. So more or less is what we are doing. Okay, the logistic regression is a model based forecasting method. The model can include different types of predictors, anything, dummies, numerical, interactions, seasonal dummies, trend and lags. That is fantastic. You can even generate very complicated equations, and that is fantastic. Variable selection methods, stepwise, forward selection, backward elimination. So you can find many ways in which you can select or provide variable selection methods, right? And I think we are going to cover that during our example. So here we have the odds, as you can see. Here we have in the dilemma to sell or not to sell, and as you can see we have the percentage sell months per year, right? And as you can see, the odds are increasing and increasing and increasing and increasing and increasing up until like a very high value, right? So I think the dilemma here is very similar to the picture, the picture that we have in here, right? So we have the odds always in our heads. These are some outcomes. We did this using the logistic regression. We will come back to this in one of our examples. So as you can see here, we have as a formula sell, which depends on the lag price and the sin, and the family we use binomial because we want to use logistic regression, and the data is a training period, right? And then we find here that we have the lag price and the sin are very significant. We are ready then to forecast very well the odds using for the GBP, for instance. Here the cell is very interesting and is telling us as well what is the dispersion, the null deviance as well, and I think in that this is using just 4 iterations in order to find the best fit. So it's very close to what we had previously. As you can see, interestingly, these p-values are less than 5%. The latest one, the sin, is just good. Yes, it just passed. It has 8%, right? It's okay. It's like having 45 in your assessment, right? It's okay. It can pass. Okay, we have here another formula. Yes, we have a different estimation here. The different estimation is using this variable here. We have again the lag price, but here we have the ratio ocus, which is a different variable that I added to just for the sake of calculating something beta. And as you can see, is highly significant. All the variables, yes, are way better. Yes, so that is improving a lot the estimation. As you can see, the residual variance here is 37. Here is just 23.03. Yes, and that is telling us that the model is fitting even more. So here we have the confusion matrix. The confusion matrix is something that probably you can, well, I will explain it to you. This is our predictions is 0 and 1, yes, and we have here like a confusion matrix that is very interesting in the following. For the first regression that we had that it has an accuracy of 64%. Yes, 64%. And this compares with the accuracy of this one, 91.67%. This is beautiful because this will allow us to actually trade. I think who wants to be 90% of the time accurate when trading? It's like when if you invest, you are having 90% of the time, you are right 90% of the time. So I think it's worth the effort, right? So the same here, we have accuracy for the confusion matrix and an accuracy of 82%, and that compares just to this percentage of 33% for the first model. Yes, so I think this is showing just that actually this one is going to be the best possible outcome. Yes, Right, so this is the reference. So in this model we have a 0 for no is not our favorite position. 1 is the yes, is when cell equal 1, so yes, that is fine. And here we have as well the number of times that the trade is doing right. We have the sensitivity, the specificity, and all of these variables we are going to cover, or I am going to explain the confusion matrix further when we play one of our samples during the lab session. I think that will be the best way to do it. I think you will understand more. And yes. So does the logistic regression outperform naive forecast? In this case, yes, way yes. The question is yes. And here we have then our same formula using cell, yes, the lag price is exactly the same forecast, but this time we use everything. We have a very good fit for our data. Everything is less than 1%. Very good. We have the significance levels, and we have here the prediction reference. So I will explain this table more for the moment being. Look at this accuracy, 87% of the time we are fine, and that is giving us like very good fit for and very good like outcome for our strategies. Okay, so here there is another example. We can use the model to forecast 2010 if we want. This regression here is for the probability of raining and or the probability of no rain. Yes, so we can use actually the example to forecast raining. I did not cover this example here because, well, we want actually to use logistic regression for something that is more economically related. Here we have the input variables, the coefficients, the standard errors. The p-values are okay, as you can see, are less than 1%, actually close, very close to 0. And here we have actually the odds, right? You can see the odds of something happening. And in doing that, I think this regression is interesting, right? At least this outcome is interesting. Okay, so yes, we have here the estimation. These coefficients come from this table, right? For these coefficients, and therefore we are able to calculate the logit function, which is minus 1.339, and with that minus 1.339, if we use the number e here, we will be able to calculate the probability of rain. In this case is just 21%. Can you see? So it's just by using this formula we are able to calculate the probability, and that is something that we want to do when calculating our tradings, right? Or if you want to forecast recessions, or if you want to forecast certain event to happen or not. I think it's like very normal in economics to try to forecast if something is going to happen or not, right? Okay, so how to improve the model? We can change the cutoff. The cutoff is like the threshold that I choose at the beginning. We can make it bigger, we can make it smaller, so we can fix in just returns that are minus 1% or higher, or we can say minus 2% or higher to be more sure of going strong in that position, etc. Yes? The idea is that we can try additional predictors as well to improve the model, and try lots of models and comparing the performance with the validation period. Obviously, in doing and including more variables, we need to be careful with overfitting. Overfitting is a problem that When we carry on including more and more variables, probably the model only works for that particular time series, but not beyond. Yes, for that time, and that is a problem that we need to be careful of when including more and more variables. This is the summary, guys. Logistic regression can be used for binary values, previous binary values, previous numerical values, trend and seasonality predictors, external predictors, interaction terms. Like linear regression is model driven. This means that you can add more variables, estimate the model from training period, we can evaluate on the validation period, and we can rerun the model and complete series to create forecasts. This is the last slide for this topic, guys. I hope that you have enjoyed, and I will go into more details about the confusion table and the other outcomes in my video, in my practical video about this topic.